So oh, we're filming. You're welcome to ask questions, but if you do, they'll pop up on the internet. Oh, here's our program from before. That was called sizeof. It doesn't look like it's a sizeof program anymore, does it? Okay. So we've got, we're using dynamic memory, and we get it via malloc. So it's coming from the heap, the data structure that's used to manage dynamic memory. We are requesting, what is size of int? 4, yeah. Good. Thanks. It's some weird thing with photo booth. It's like a new feature, but thanks for telling me. It freezes, so I don't know why. It seems to have worked well as I'm taking the videos in class, but as I've done some at home, it freezes. I don't really understand why, but good. Thanks for pointing it out. So size of int is, let's say it together. 1, 2, 3,
4.
Great. So 4 times 100, so we're requesting 400 bytes. And when we print size of x, the answer is going to be what? 1, 2, 3, 8. Okay, so let's do it. So first off, 2 things. One is, and we'll talk about it later today, that if we want to do malloc, we have to include standard lib.h. I will talk about that later in this lecture. The other thing is, size of actually returns not an integer, instead it returns an unsigned long. And so an integer has a %d, but an unsigned long has a %lu. So it said for my printf, it gave me a warning saying that really should be a %lu. So why is it 8? The answer is that size of is not a function that goes and looks at this pointer and says, aha, that address, you've gotten it from the heap, let's go interact with the operating system and figure out how much memory was associated with that address. That's not what sizeof does. What sizeof does is it tells you how many bytes are associated with the type. The type is a pointer to an int. All pointers are 8 bytes. So sizeof will return 8 bytes. If we change this to be 1,000, we'll still get 8. If we change this to be a pointer to a character, we'll still get 8, because all pointers are 8 bytes, and sizeof is telling you the size of the type. If we said size of int, we'd get 4. If we said size of car, we'd get 1. And if we said size of int star, or car star, or anything, it'd be 8, because all pointers are 8 bytes. Okay? So there's a separate thing. Okay, fine. Sizeof didn't do what I want. What I want is when someone hands me an array, a pointer, to know how much memory is associated with that pointer. That does not exist. So it's up to you to pass around something with it. It's up to you, for example, to keep track and to have a length equals 1,000 or something. Or in the case of character strings, there's this convention where you terminate it with no characters. And by having that convention, you don't have to pass around a length. Okay? How do people feel about those concepts? Thumbs up, thumbs sideways. Parker, yeah, good. Parker, what do you got?
Why do we use sizeof in these formats?
Aha, great question. The question is, why are we using sizeof if we know an int is 4 bytes? So, that's actually a really great question. So, an int, you can assume everywhere you go is 4 bytes, but there could be future architectures where it's not, right? And so it's a matter of future-proofing your code and portable code. There's also a notion of documentation, right? If I look at something and it says malloc of 4,000, then that makes less sense to me than malloc size of int times 4. So the documentation angle is valuable as well. Especially with pointers, there was a big shift from 32-bit to 64-bit, and that was something where a lot of code that had baked in this abstraction that the number of bytes associated with something could change, that was good. But yeah, so I understand. I am really playing two different arguments here. I think you're exactly right to point it out. On the one hand, I'm saying, hey, an int is always 4 bytes, and you should know that. And on the other hand, I'm saying, but keep it general just in case. And it is more of a just in case. Simon?
Why does automatically allocated array?
Yeah. So let me say, so Simon's question is about this. If I say int x 100, it actually will do the thing you want. I don't believe you should really even do this. Like this one is okay. Once you start getting, you guys like this sort of stuff, and I know we talked about it last class, Simon, where you do this. So to me, stuff that's on the stack that's an array, it's getting into wonky territory, and I agree. If you do a size of it, you'll get the right answer, but I don't entirely trust it, and I don't really want to do that unless it's small numbers that aren't going to change. So, but I accept and agree with your point. If it's an array that's on the stack, then it will do it. Yeah.
In the print statement, you just write x instead of sizeof.
Okay. The question was, in the print statement, if I just wrote x here, so x is a pointer. So I think what's going to happen is it's going to tell us that because we're telling the print statement, look for something that's an unsigned long. And if we send in a pointer, it's going to say, look, I'm trying to print an unsigned long. You gave me a pointer, and it will just convert that pointer to an unsigned long. But it's not going to go do the thing you want to go figure out that there's 4,000 bytes that have been requested along with that pointer. That's your job to keep track of. But we can do it, and let's see how it goes wrong. So you see, it says the format specified we were doing an unsigned long, but you put in a char star, and it's saying, really, because you have a char star, you should be using the %s type. But if we run it, then we get this, and I'm willing to bet if we converted this to hexadecimal, it would look like a pretty normal pointer. Yeah? Can we use what? Can we use? Yeah, good. That would actually be much better, wouldn't it? Because we have a pointer to an int, so we should be using a pointer to int. Thanks for pointing that out. Yeah. I mean, so let me say, there's again, C, no seatbelts, right? So maybe I wrote this wrong from the beginning, or maybe I changed it midway through. I can't remember which, but this is definitely weird code, right? And not I like your version much better. So this says the size of int is 4, and so that means we're allocating 4,000 bytes. And really, this just becomes 4,000 bytes. Now, that means in terms of characters, we'd have 4,000 characters, right? But if I saw code like this, I would think the person didn't know what they were doing, right? That seems like a bug in the making. So you would definitely expect it to be that you're saying, I'm allocating 1,000 ints, and I'm treating them as ints, because this pointer is very important in telling the compiler how you want to interpret the data, right? If you say char star, the compiler wants to treat it as characters. If you say int star, the compiler wants to treat it as ints. So thank you very much for pointing that out. Okay.